Okay, welcome everybody. This is our weekly OPI Lifecycle Provisioning Technical Working Group. Today we have a couple of items on the agenda. First is we have NVIDIA and Marvell wanted to come and present how they do the unique identification between VFs, PFs inside the host versus inside the DPUs. Then after that, we have Summer from ARM that is going to start the discussion regarding the standardization of secure boot, root of trust, TPM, and device attestations on the DPUs. So with that, since NVIDIA didn't join yet, let's start with Prasad Marvell.
Yeah, sure, thanks. So let me just restate the background because I got this as part of an internal meeting within Marvell and just want to make sure the topic is right. So we are talking about a mechanism for the DPU to identify the VFs and PFs that are on the host side and the ability to configure via maybe OPI API any prescribed rules or settings corresponding to that PF and VF. Is that summary accurate?
Yes, doesn't have to be OPI API yet. We can, just start with a simple discussion of using the standard command line tools, Linux tools to identify. But yes, the goal is if we having hot plugging or statically provisions VFs and PFs on the host side, they go in through the PCI Express enumeration and getting the BDF addresses. And we need to make sure that the representatives inside the DPUs of the same VFs and PFs are uniquely identified so we can assign accordingly MAC addresses, IP addresses, and doing, plug into OVS and stuff like that. So that's the reason for this conversation. Make sense, Prasad?
Yeah, it makes sense, and I do have a question on that front, but I'll get to that. So, so the nitty-gritty in terms of how this thing works on the Marvell DPUs is that we have hardware registers that we can query on the DPU side to know the BDFs that have been assigned as per the enumerations on the host. So that allows Marvell to know, the Marvell software to know using non-standard mechanisms. It's obviously not standard, but there's a way for the software on the DPU to know what the host side assignment is. So
can you explain a little bit how like BDF is assigned by the host Linux? Let's say we're talking about Linux after enumeration. Can you a little bit describe, or it's IP, that's fine. But how, if you can talk about how you propagate that information from the host to the DPU, like do you have an agent? Do you need to have an agent on the Linux side to communicate the BDFs, or how that works?
No. So this is where I thought Satanand can fill in exact details, but what I understand is that we have a sense of the number of PFs and VFs that can be created, and we are able to predict the sizes of, how should I say? So if you imagine our entire if you imagine all channels between the DPU and host as a logical sequence of entries, let's say I have 10 such entries, and if the host side creates 2 PFs with 2 VFs each, we are able to predict where the 2 PFs will land. And there is information in the registers as to where those PFs and VFs were created. So it's a function of how those PFs and VFs got allocated in that logical array, if you will, and we are able to query that information. So Satanand has more minutiae details, but we do not run any explicit software or agent to do this. It is part of our.
So drivers that is running on the host by Marvell, obviously, is not communicating that information to the DPU, or
that is correct.
I think it's implicit, Boris, that when there's configuration cycles on the PCIe bus, the PCIe device is supposed to learn its BDF value and store it. And so I think what they're doing is capturing those values as enumeration occurs, and then they're exposing those through this register array that Prasad is talking about to the DPU software.
So the BDF is communicated during the configuration cycle, and then they can store it and then fetch it through the tools on the DPU side.
That is correct. So I see Satanand has also joined. So if you have more pointed questions, I think he can elaborate. So Satanand, I was just describing that Marvell DPU can learn the PDFs that are configured on the host. So I think there was a question about lower level detail of how exactly that gets done and whether you want to share it or not. So I'll leave it to you.
Yeah, so we capture that during the enumeration cycle. Yeah, that's a general way everybody has to do, PCIe being a serial bus.
Yeah, because I mean, in support of re-enumeration and hot plug, your bus might actually change dynamically as an endpoint. So you have to be monitoring your bus number and adapting to whatever comes to you in your configuration cycles.
All right, yeah, and then so then we're using proprietary Marvell tools today, right, in order to query that from the DPU side, right?
Yeah, I believe so. Satananda, right? There's no standard way to expose that on the DPU, right? There's no standard software.
Yeah, there is no standardized way to do that, right? Yeah.
The API team was talking about unique identification as well, not just the BDF. They thought that we can, on both sides, expose, for example, a serial number of the device as well, if we have servers with multiple DPUs. So we want to identify like which VFs and PFs belong to each DPU, so in a programmatic way. So they were thinking about, can we communicate also using, I don't know what, like maybe VPD or something like that, on the PCI Express of each VF and PF in order to communicate like serial number and, some more information, or you think that's not necessary?
Okay, so maybe at this point, I'll go back to your summary. So if the subsequent configuration to be done on the DPU can be done using the PF VF identification completed by the DPU, then we think that is sufficient. We do not need any other detail. As long as we are able to map and know which host side PF VF and what its corresponding underlying logical channel is for the DPU, and then any configuration we know is guaranteed to be applied on that PF VF. So then that is sufficient. I think in our internal discussion, I think Satanand was also alluding to the NVMe API, which I'm not familiar with, but I think he is using similar mechanisms. So we think the VF PF ID is sufficient. No additional information is needed on the DPU for subsequent configurations.
Yeah, basically, if we have the VFPFs plugged into different containers, pods, or virtual machines, each of them have different, subnets and VLANs and all of that. We need to match that configuration on the DPU. So that's why the need came from unique identification of two sites. So if we have network device created on the host, network device, corresponding network device created on DPU, and that network device is plugged into Open Virtual Switch, for example, we need to understand like who is who. So if it's just the pair, the tuple of VF ID and PF ID, maybe plus BDF, because we know the BDF, and it's different BDF on the host side and different BDF on the DPU side because it's different root complexes, right? So enumeration is completely different. So we have two BDFs that we need to worry about. And we don't have a serial number, so yeah. Then you have a question.
So
yeah, I was going to say, sometimes we just give an individual queue out of the VFPF to a container, and that represents can have its own MAC address and all that stuff. So it might be a 3-tuple, not the PF and the VF you might need PF, VF, and Q.
Tim, you had a comment?
No, I was just observing that really we're talking about a multi-root domain problem here, right? You have a root domain on the ARM complex side and you have a different one on the host side, and you're trying to establish this mapping of PFs and VFs between the two.
Yes, exactly. Because we need to apply the same configurations on both sides.
But I wouldn't use the term multi-root because that it has different implications.
Yeah, I was trying to be careful about that.
Two
Yeah.
root complexes.
Yeah,
Two
it's a
root
root complex sandwich.
So going back to the unique identification, again, the API work team requested if we can think about something more than just the BDF and PFVF queue tuples. Can we add somehow the serial ID, serial number of the device or something like that into identification that we can query on both sides? And the second is, can we standardize on the same way inside, if you inside the DPU and you're writing, let's say, CNI controller running on the DPU, can we standardize on the way we query that information from the device or the virtual physical functions representatives on the DPU instead of having the proprietary implementations across every vendors?
So you've suggested VPD a couple times for us, and it felt like there were some people who were resistant to that idea. I'd like to hear why they think it's a bad idea.
Sorry, what was the suggestion again? Can you repeat that?
Using VPD as a mechanism on both the host and on the ARM complex side to sort of communicate a tag, a handle, or a label, whatever it's based on, but using the VPD in the configuration of PCIe mechanism to communicate that information.
Or maybe even generate UUID for each VF and PF and communicate the UUID, which is truly unique, to both sides.
Yeah,
Instead of-
VPD use would be a abuse of VPD, right? Because VPD is meant for something else.
But we have serial number in VPD, right, of the card. In the vendor, in this serial number field of the VPD.
Is there a case where VPD ever changes for a product? For example, if I have less number of VFs or if I have more VFs and PFs and all that, would the VPD change? And is it expected that VPD changes even if the hardware is exactly the same?
VPD is supposed to be based on a unique serial number that is generated out of all the FRU units on the
Correct.
card, right?
So Satan,
So-
I'm agreeing with you. I'm basically saying that, if this is more of a hard-coded data about a device, do we want to propose having dynamic information there? That's where I'm going.
Okay, so I just want to go back to the original question. So I still didn't get why VF and PF IDs aren't sufficient to be the root of the configuration. I understand additional queue information that Dan mentioned. That's okay, but why wouldn't that be sufficient to uniquely identify the VF PF on the host that you're trying to configure for? Why do we need?
I can only guess. I can only guess, Prasad, but let's say in Kubernetes environment, you have a master nodes that in control of everything. So if you want to uniquely identify the network devices across the cluster, for example, one way to do it is, implement an agent or use existing agent, I guess, on each node. Then each node will report back, these are my virtual physical functions, and will attach its serial number, or we can do it uniquely across the cluster. But somehow we need maybe, I don't know, I'm guessing, maybe we need a unique identification of VFs and PFs across a cluster of nodes.
Okay, so this is beyond the original problem statement, right? So the original problem was, how can the DPU know the VF PF for the host it's attached to? So for that, VFID PFID is good. So you're talking about in a cluster of multiple DPUs, multiple nodes, you want to be able to identify. Okay.
Yeah, and then maybe there's a different solutions, that's fine. But I think, yeah, we have three things: a single DPU in a single server, then multiple DPUs in a server, or maybe a single DPU in multiple servers. That's also an option, right? And then we have a cluster.
Okay. No, I don't have any specific comments on that.
So associating UUID with network devices, that has to be done at a OS representation level, right? For instance, Linux NetDev has to have some field that you can query using a tool or something that says this is your UUID, and you should be able to set or get those. Unless
you have a lot of tools,
associate,
ETH tool and IP, right? You have a lot of those fields that you can.
yeah, unless you can associate at that level, maintaining tables of UUIDs elsewhere will not help, is what I'm thinking, right?
Mhm.
Because
yeah, I was thinking like when you
Linux,
hot plug, you can auto-generate the UUID and then you can populate it in some database, like not outside database, but in that one of the fields that standard, I don't know, ETH tool or whatever you can query that.
If we consider the scalable I/O in the future, the PFBF might not be a compatible identifier for the scalable I/O technology.
SIOV?
Yeah.
Mm-hmm.
That's why I mentioned Q, is that would cover it. That hit the third part of the tuple.
but PASID would be a better option, right?
What would be a better option? I missed that.
PASID, PASID.
Yeah, it's arguable. Yeah, but you really just need a third identifier, and just make sure you have that covered.
But I want to make sure that people in the call, they understand the need, the ask, right? And we can continue the brainstorm on different ideas, but just wanted to make sure that everybody sees the value of us discussing that deep dive in that and creating a standard method for communicating that kind of information and maintaining a database somewhere.
I think though that there's a fundamental question about certainly. So we have something similar in OpenConfig that we built out in the IPU, but it assumes that this is only being exposed to the CPU complex on the card, and it doesn't get into any sort of information on the host side because the host is untrusted. So if you wanted the host to be privy to this information, it would have to be transferred at a higher level of abstraction, which we absolutely do in some of the recipes, but it's layered. So it doesn't sound like you have the same layering that we've used in the past. It sounds like you're trusting the host a bit more than I think we would by default, right?
I think we still can have two modes, right? Then, like you was always advocating that mode that the host is untrusted, where this information is not communicated, and mode when host is trusted and this information is communicated. Anyways, even if host is untrusted, this is just a query information. I don't see a problem sharing that UID of the device, like if we can figure out how to do UIDs.
No, you can't do that if the host is untrusted. Like if you're doing bare metal hosting or something like that, you can't share the UI, especially the VPD, which would be tell you what type of device is underneath. You can't share that information.
No, that's fine, but UID, I don't think it's a problem to share, right? It's opaque. It's not representing anything.
No, it would be specific to that device. It would be assigned to that device. You could use it to look up what kind of. I mean, if you can build an attack around
random generated, it's not something that is fixed to the specific vendor or device. I think that as we hot plug new virtual physical function, I was thinking we can create some auto-generated random number. You can call it UID or whatever. And this number is just represented to two sides exactly the same way.
I still think it's TMI. I think that if you just use the PFVF and either pass it or queue number, that would be sufficient. Then you don't need to have an auto-generated number that's specific to anything else.
I don't have a problem with that. I'm just saying, okay, let's say if it's PFVF and Q or PSID, whatever it is, right? First of all, can we standardize on the tuple? And can we standardize on the tools that give you that tuple on both sides?
Okay, yeah, I'm aligned to that.
Anybody has thoughts? Can we? What is
Yeah, I think from Marvel side also we agree on that.
Because the nice thing about that tuple is that it's part of it. That's regular information any host can get. It should see the device PFVF, PASID, Q, whatever. It should see it locally, so that it knows what that is. And so they can associate that with the whatever device popped up in on its bus. So that's all readily available information.
Yeah. So Satananda Prasad, can you describe this, a proposal, and then we can all kind of review it, and then your input, obviously from Intel perspective and everybody else, and obviously Vipin from MD Pensando, then we can describe it, review it, and merge it once approved.
Yeah, I'll work with Chetan on this internally.
If you don't have cycles or somebody else wants to volunteer, maybe Dan, Intel wants to lead that, I'm fine with either way. I'm just looking for a concrete action that we can create a proposal, we can review it, and we can publish it and say this is a new spec. All the DPUs and IPUs have to follow that way for communicating the unique information to the host and to the DPU for the applications running on the host and applications running on the DPU to be uniquely identified the same VF and PF.
If people don't have cycles, I already have a proposal for this in the scalable IOV forums, so we can just pick that up and reuse it. If I guess it's zero effort on my side, so I'm happy to offer it.
As long as it doesn't say IPU Intel, that's fine.
No, it's specific to actually this work is on our NICs. It's not an IPU effort. So I'm happy to grab it and present it here. It's a 3 tuple like we talked about.
I have no problem with that. Satananda, what do you think?
Yeah, I'm fine with that.
Okay. Vipin, you want to review it and present back next week, or you want to kind of follow this, or what is your kind of?
Yeah. I think I would say that whatever Dan is proposing, let's review it. I will comment on anything if it is differing from what we are seeing.
Let me put it into the wiki or in the markdown, and then we can decide if it's good to talk about for next week. I'll get it in the wiki, in the markdown, whatever we call it.
And Mark, can I ask you to bring this back to the API group to ask about the unique identification with UIDs or serial numbers, just to clarify what the need is? Because if I understand correctly, I don't see yet the people on this group didn't see an interest of adding the unique identifier.
Yeah, we can bring that to the API group.
Thanks. Okay. Anything else? Steven, yes. Go ahead.
Hey, I was just going to point out, I think a big part of why for Kubernetes they were looking for some way to uniquely identify is to help in the correlation between two, from a Kubernetes perspective, you have two separate nodes here. You have the DPU and you have the host. Is being able to correlate which DPU node corresponds to which host node. How do you do that correlation?
And the idea is to use the network devices to correlate between those?
That's certainly one way to do it.
Mhm.
We need a way to do it.
Yeah, we used this 3 tuple in the past. That's what we've done.
But shouldn't that come from the BMC, MC info of both? Like the BMC DMID code on the host should show the DPU presence.
It shows that a DPU is present, yes, but how does software that's running outside of these things know that this node, which represents a DPU, is physically attached to this node, which represents a host?
Oh, but we have that in DMI code info, right? Which we, did the gRPC for inventory, and we have that information already.
Right, and I think that is depending on VPD.
I'm not sure about that, but I mean, the problem is normally with OVS on a host with a SmartNIC or just with the software, you can just you have the 2 sides of the wire and you just connect them together in memory, and it's really easy. But the SmartNIC or the DPU IPU creates this level of indirection, and so now you need to you can't just connect them through directly. You have to go plug each side into a hardware device. And so that's that layer of indirection where you use the BDF plus PASID or BDF plus port plus Q to do that connectivity, and then you need to tell the IPU DPU on the other side that, oh, inside the host I connected this VM to PF1 PF3, right? And then it knows that its internal handle for that, it can go look that up, and then it can hook up OVS to that port accordingly. So it's that layer of indirection that's happening in potentially 2 separate hosts, two separate compute complexes that needs to be coordinated.
I think that, Stephen, what you're saying is of matching the DPUs to the host is more a static kind of information. So yeah, probably for that we can either use VPD or I don't know. Let me look back at the SystemBIOS how he gets all this information versus the virtual physical functions, which are much more dynamic nature, I would say.
Right. Yep. Exactly. So there's 2 separate pieces to this. One is, in a Kubernetes cluster where you've got multiple hosts and multiple DPUs, is how do you do the mapping of which hosts and DPUs are connected to each other, physically, which are associated with each other. And then the other is, okay, now I've got a host and I see a VF. How do I know which VF that is from the DPU's perspective?
Yeah, that makes sense. Yes. So I do think that the first part we addressed already using the SystemBIOS, so we can look into that, whether it's good enough or not good enough. And the second part, we'll wait for Dan proposal. Dan, can you do it by next week meeting?
Yeah, no problem.
Yeah.
I'll
And
try to
so
get
on the,
something.
I was gonna say
Yes,
on the VPD or on the SystemBIOS, I think we were using things like serial number, which I think were coming from VPD.
Mm-hmm.
And that was one of the things that NVIDIA was objecting to, was because they said that their board partners usually don't bother to fill it in.
Right, I remember that. The VPD comes from through and the EEPROM is not populated if the card is not built by NVIDIA.
Right, exactly. When they're just selling the chip.
Okay. Okay, so unless anything else, we can switch the discussion to secure boot, root of trust, TPM, and device attestation standards by Summer.
Thanks, Boris. Let me share my screen. 1 second. Right, can you see my screen?
Yes, it's up.
All right, so I'd like to talk a little bit about ARM system standards and requirements in general first, just as a background. Sorry, I think I'm sharing the wrong screen. Give me 1 second. Are you seeing the screen with the slides?
Yes, we see the ARM system requirements for standard OS boot and security.
Okay. Thank you. Sorry, I have too many screens. So I'll start with a quick background on system requirements in general, talk a little bit about server requirements and how these apply to DPUs, and the certification program behind those requirements. And then we'll spend the rest of the time focusing on the security specific requirements. So I'll go quickly over the background just as to set the tone. So to get started, some of you may be familiar with this, others may be hearing it the first time, but ARM has a program called SystemReady, which is a certification program that we work with the ecosystem for everything from IoT and edge devices, computer networking, all the way to data center, cloud instances and enterprise systems. And the idea is to move away from the fragmented approach of a BSP or a firmware and OS combined board boot package that is specific for every hardware that allows you to only boot that OS that is integrated as part of the firmware or part of the SDK for that device, and limits the maintainability of the software applications running on that device. So move away from that model to a model where we have standard firmware and hardware requirements implemented across the board in all the devices, providing standard common ways to boot off-the-shelf operating systems and hypervisors, and allowing this standard and diverse ecosystem of software applications to run on those OSs, just like they do on other architectures. So this is called SystemReady, and I put a link there so you can get more details. I'm not going to go into the details of the SystemReady bands or categories of certification, but just to say that the program is tailored and customized a bit for the different market segments, because the needs are not exactly the same for servers and embedded devices, for instance. For what we are interested in here, specifically for DPUs, we have the SystemReady ES, which is more for like embedded servers, if you would say, type machines. So machines that are very similar to servers in nature, but maybe in a more embedded form factor. Although you could argue that even DPUs could fit in this form factor, and that's what we envision SmartNICs to fit in this band. But they could very well as well be, let's say, SR certified if they are seen as complete servers, just in a small footprint, or they could be more embedded type IoT type devices if they don't have the common server functionality like a BMC, for example. There are a number of requirements that we have, ranging from silicon, hardware, firmware, all the way to security specifications. All of these are available publicly. You can take a look at all of them. Some that may be of interest to this group are the BBR or base boot requirements, which have a specific recipe. We call it a recipe. So the SBBR is specifically talking about UEFI, ACPI, SM BIOS, making these systems look very much like standard based servers or PCs. There are extensions to those requirements that are specific for the security. So we separated the base boot requirements from the security requirements. So in SBBR, you will not find mandate, for example, to implement TPM or UEFI secure boot, but those are required with the in the BBSR or base boot security requirements, along with a checklist that we'll talk about that show guidelines on implementing platforms securely. As part of the certification program itself, the SystemReady certification, we also have a special category of certification that is an optional additional qualification and certification stamp that is specifically on implementing those secure interfaces that are defined in the BBSR. So you can have a device that go through the base SystemReady certification for complying with the firmware, let's say UEFI, ACPI, SM BIOS, and all the silicon and hardware requirements, so you can boot a standard off-the-shelf OSs without customizing those operating systems. So that's the base SystemReady stamp. Then in addition to that, you go through another qualification on top that makes sure that UEFI secure boot, TPM measured boot, if there's update for capsule updates, it's done using secure updates, etc. All of those are implemented properly. And then you get an additional stamp for the security extensions on top of the base stamp. For
so just to pause 1 second on this, like my view is we need as a group for all the DPUs and IPUs to standardize on those things. Like if anybody is thinking differently, like I need to understand and to know about that, because we feel that this is an absolutely need that comes from the customers, and we need to provide that level of standardization for DPUs and IPUs.
Yeah, and I'll go into details of the specifics for these, but you will find that they are very common to what you are familiar with on servers.
Okay.
We do have a compliance suite that tests all of these requirements I just mentioned, from the silicon to the firmware, UEFI, ACPI, SM BIOS, all the way to the secure interfaces, including secure boot and measured boot. The entire test suite is open source. It is based largely on multiple open source components that specialize in testing specific firmware interfaces, like the firmware test suite, which runs in Linux, or the UEFI self-certification test, which runs in a UEFI shell. We added a number of additional tests and applications. Some are in the process of being upstreamed, but they're all open source, and the whole package is available as a pre-built binary, as well as open source that you can compile yourself. So that was just a quick background of the program of the certification and the general approach to standards-based design. Now let's talk a little about security on ARM platforms. So as a first principle, the idea of booting from an immutable root of trust to authenticate your first firmware components and then continue the chain of authentication is well understood and well established, and is adopted by ARM in our standards around server design or system design in general. And we talk about this a lot. A lot of this material is already public or presented in other conferences. So there's really nothing strange here. in terms of specific technologies that may be employed in the chain of trust, there are a lot of standards around that we also adopt. So things like the SPDM for the security protocol and data model, things like the CMA and PCIe for component measurement and authentication. All of these are standards that apply to ARM systems as well. Now, if we are talking specifically about the view from the OS point of view, the OS that's running on the DPU or on the ARM system, then the focus becomes just on those firmware interfaces that are presented to the OS to ensure the secure transition between the previous phases of firmware to the operating system and allow the OS to rely on those firmware interfaces to establish its own security guarantees. And those are the topics specifically covered in this specification, the BBSR document. Secure boot is a strong emphasis in that document, and with very specific requirements numbered with items and in tables that outline what is required for the secure word firmware, for the normal word firmware, what would be the UEFI firmware, requirements around the secure boot key management, requirements on the UEFI authenticated variable interfaces that need to be present to the OS. If you read through these requirements, you may find that they may be a subset or very specific to ARM at the first glance, but they are really just derived from the industry standards and not that much different from what you see on common implementations on servers or other architectures. In addition to UEFI Secure Boot, we have very detailed requirements around TPM measure boot, including the usage of the UEFI defined protocols that are defined by TCG for logging the events during the UEFI boot.
And Samer, can you also talk about differences between the TPM and ARM Trust Zone?
Sure, yes, I can. The ARM Trust Zone is what provides the secure word security that you see here in this box in the TFA. So the TFA firmware mostly runs in secure in the secure world on the ARM processors as part of the Trust Zone. That is chained to the immutable root of trust as well. So the firmware that runs there is authenticated, and in turn, the firmware that runs on the normal word side, like UEFI, is authenticated before it runs. And there are some interfaces that I'm not going into details here, but if interested, I can bring them up. There are interfaces called the Secure Monitor calling convention that allows the normal word firmware UEFI or even the OS to call back into the secure word provided by EL3. EL3 is an exception level in the ARM architecture where the secure word interfaces are running. So you can call back using those interfaces, those SMC interfaces, to get some services or data from the code that's running in secure world. There is a whole other presentation that we can do that's maybe another hour around what level of security you can use secure word and trust zone for things like secure partitions and allowing to load applications that can run in isolation in a secure level that is managed by trust zone. And there are applications for that are very interesting, including things like firmware-based TPM that we can also talk about if there's interest. However, all of this is stuff that happens on the ARM CPU in that isolated secure word part of the firmware. you still need to provide the standard TPM interfaces and services for off-the-shelf operating system to use if you want to use features of the OS that are tied to measured boot. So trust zone and the secure word side of the firmware does not necessarily replace the need for TPM and does not provide the same functionality. For lack of time today, I will stop at this, but if there is interest, we can do a whole deep dive on firmware TPM versus physical discrete TPM and what trust zone can do in terms of secure partitions and other useful applications. For the sake of time, I'll just keep going for today's presentation. Part of the requirements for TPM, like I said, is to provide a standard UEFI protocol for collecting the measurements on pre-boot, and we do test this interface to make sure before grub is started, before the bootloader starts, the operations of logging the events and the support for the different hash algorithms and capabilities of the TPM are all exposed properly in the pre-boot environment. So we do test for that. We do also have, I don't show it here, but we have tests that look at the measured boot log, at the TPM log from Linux. We do have tests that go through the UEFI secure boot enrollment of keys and then verifying in both UEFI and in the OS that only signed applications are allowed and revoked signatures will not run. So that's all covered in the requirements and in the certification tests. Now, switching gears here and talking about two slightly different but related topics that are also available in the ARM ecosystem. The first one is called the Platform Security Architecture, or PSA. PSA actually now is being run as an independent program. So this is not necessarily just ARM. This could apply to any architecture. And the idea here is really to move IoT style devices or embedded devices into a secure implementation that provides the immutable platform root of trust, the ability to boot and OS securely, update firmware securely, provide attestation for the device, anti-rollback, etc. So this is independent of UEFI secure boot, but it can be part of the chain of the implementation for UEFI secure boot with that ROM and trusted firmware that I showed in the previous slide for UEFI secure boot. It's not required to do PSA in order to do UEFI secure boot. You could do platform-specific implementation of the root of trust and the measurements up to the UEFI firmware starts, and then from that point on, it becomes a standard UEFI secure boot story. Or you can do PSA for that early part up to the UEFI firmware, and again, it becomes a standard UEFI secure boot story. The PSA certified program also offers its own testing and certification at different levels. Starting from the silicon, making sure that you have that immutable platform root of trust and what guarantees it provides, to all the way to the device and the capabilities of the security of the device itself. So things like in trust zone, what you could do is covered under PSA. PSA does not talk much about the operating system interfaces and the security to the OS. That is covered by SystemReady and the BBSR that I said earlier.
Is PSA specific to ARM, or?
It started so, but it's really now can be implemented and certified, I think, independent of the architecture.
Because, something like a UEFI secure boot is pretty generic, but I think that for OPI, we would need something that wasn't ARM specific. so that we could, apply it to the different types of devices, even the ones that aren't ARM-based.
Understood. And I think for earlier, with everything that we were talking about in this BBSR, even though the specification, the requirements document is written by ARM, it's all based on industry standards. And we can go and do a deep dive on this document and see if any of it really does not apply to non-ARM systems. But I would say this is a very good starting point rather than start from scratch, because it's using industry standards, not ARM specific interfaces. And those standards are already supported by the operating systems. And that's the case for UEFI secure boot and for TPM measured boot. For PSA, I'll have to get back to you with more details on that. I only had those 2 slides about PSA today, but you can check the PSA certified website as well.
Okay.
And finally, I would say there is also a platform security checklist that we provide in the BBSR specification, because just implementing the firmware interfaces to the OS is not sufficient guarantee that the platform implemented those interfaces securely, right? You can have UEFI secure boot and measured boot, but if the UEFI firmware is not locking things properly, for instance, or is not based on an immutable platform root of trust, then those firmware interfaces do not mean much in terms of guaranteeing security. The OS thinks that the firmware is secure and can use it, but malware can overcome because of the weak implementation. So we try to provide a security checklist on guidance for the secure implementation of all of those interfaces. And that's where PSA can help as well as an independent certification program. The last thing I would add is these DPUs also have BMCs, so we look at them as managed devices in some cases, right? Which make them look like really servers. And for servers management and security, we have additional specifications that talk about the server-based manageability requirements and what are the different use cases of the platform root of trust that is independent of the ARM CPU that manages the whole board, including the BMC firmware and potentially attestation to IO devices firmware. And we have literature and guidance and even compliance test suite that we write around that as well. And that's what I had for today.
Thank you, Summer. I think this was a very good overview. And I'm going to ask the team again, like, do you feel that this is something we need to standardize on? I personally do, but I want to hear, others to express. If yes, we're going to deep dive on this. Yeah. Yes, Dan.
I feel like a lot of this has been standardized. We'd want something that is standard across x86 and ARM. And if it's not standardized, I don't think that OPI necessarily would be the right body to go and fix that. So it really becomes a question of like, what is already standardized across servers, and what parts of that standardization can we reuse?
Exactly.
That part, 100%. I am fully behind. We need to do that.
Yeah. I didn't mean for us to write new standards. I was saying that we need to deep dive on what Summer presented, look at all the standards that we have, and adopt the ones that we all agree upon, publish them on our website, and DPU, IPU vendors will have to implement those standards if they don't already.
Yeah, I think the first thing we're going to stumble on is the question of, is this DPU, IPU a server? And do we follow the standardizations that have been happening across x86 and ARM servers, or is it something different? That'll be a fun one. But I don't know if it would be really great if we could all answer that question consistently, but that's probably like the first order bit.
Yeah, and for that, there might be two answers, right? If it is a server, here is a set of additional standards. And if it is not, then maybe it's a subset.
Yeah, I like that.
And then we will have same question or problem we discussed earlier this call when we have two PCI routes, and then we need to coordinate between them. Same here, we will have two root of trust. One is DPU, IPU, and one is server. And then what's the coordination and how they talk to each other and how they trust each other.
And I think, yeah, that's a valid question, Andre. And I think we also have some standardization in that space, whether it's SPDM or something else, but definitely we can discuss that as well.
Yeah, but do we have, I think it's about how these two systems, which when each has an independent TPM or SPDM or whatever, how they talk to each other and how they trust each other.
Mm-hmm.
I think that's a question as well, because last week when we presented on CSC our use case for remote management for GPU, IPU, I think it was one of questions was, okay, and we can trust IPU, but then how we can trust host this IPU is sorted to. So I think this will be, again, it's a good topic for discussion.
Yeah, I agree. Today we have a standards for example, SPDM, how the server can trust the peripheral devices. I think this is the most kind of core of the standard. So using the SPDM protocol, it can establish the trust to the peripherals, but that's a little bit different. But yeah, that's in scope for sure. Okay.
I think that was about the joint attestation concept as a comment that came in the TSC discussion when we have the multiple root of trusts. Yeah.
Yeah, actually, Boris, we presented it last week on TSC, our use case for remote manageability. Again, it was recorded so people can review it, but if people are interested, we can present it here as well for our remote manageability use case.
Yeah, good. No, if it's recorded, I don't think we need to repeat that. But if people have questions, for
but
sure.
Exactly. So if people can review it and then they can have questions, we can maybe spend some time here to answer those questions.
Excellent. Post it on the Slack so people have the link and then we can discuss it. Yeah.
Okay. Yeah. Thank you.
Thanks. Okay. So see you all next week. We'll continue the three topics that we have in mind is the VFPF unique identification, the continuation of secure boot root of trust, and then we also have our non-finished business with boot coordination and a reboot new page that I created. So we'll continue all that discussions next week. Thank you.
Thank you.